Hello students, welcome back to All 4C Learning. In previous session we learned Raman-Raman reaction. In Raman-Raman reaction, phenol upon reaction with chloroform in presence of alkali, we are getting ortho-hydroxybenzoaldehyde as major product and para-hydroxybenzoaldehyde as minor product. Now, we are going to learn if ortho and para positions are blocked in two different situations, then which product you are going to get as major and minor. Have a look here. Phenol, let us assume that ortho position, a para position is blocked by methyl group. Now the question is, because of we blocked para position, are you getting 100% ortho product? No, not like that. Ortho product is major, but some para product also formed. Let us see what happened, how the reaction proceeds. This one upon reaction with dichlorocarbon. Already we learned in the previous session how dichlorocarbon formation takes place. Alright. Now this dichlorocarbon has to come and attach to ortho or para position. Here you are getting products. Two products are possible. One is as usual aldehyde group is in ortho position, and the second product here what you are getting is like this product, CH3 and CHCl2. How these are possible and what mechanism proceeds, let us see here. As usual, phenoxide ion, this one is ortho para directing group. Being ortho para directing group, this CCl2 has to, here the methyl group also in para position. So this phenoxide ion is involved in delocalization. Oxygen containing lone pair is involved in delocalization in phenoxide. Resultant we are getting two resonance structures in which one of the position negative charge is located in ortho position. Negative charge is located in ortho position like this. And one more possibility like this. Now these two resonance structures are participating in delocalization reaction. Now with this carbon ion, let us consider this carbon ion means carbon ion in which negative charge is in ortho position. This one upon reaction with CCl2, then we are getting the regular product. This one OH and CHCl2, here CH3, means first here CCl2 attacks, because of it acts as electrophile, and this one is a nucleophile. There will be new bond formation between these two. Resultant we are getting CCl2 minus. As we learned here, this one exists as double bond. This one exists as double bond like this. Now here hydrogen also there. Upon losing of this proton, here you should remember that where this electrophile, where to which carbon electrophile has to come and attach, at that particular carbon hydrogen is there, and when the ring reattains with the aromaticity, CH sigma bond is going to break down, and these pi electrons are shifted like this. Then we are getting product OH and reformation of aromaticity of the ring. Here you are getting CCl2 minus. This one upon hydrolysis, we are getting product OH and this CHCl2 and CH3. Further hydrolysis, we are getting ortho product OH, CHO, CH3. In this case, if you observe the mechanism, is just similar to the mechanism what we learned in previous session. Now, instead of this electrophile has to come and attach upon ortho, if it goes to para, then what happens in this case? If it goes to para position, that means we need to consider this negative charge, means carbon ion. Then we are getting C double bond O, here methyl group and also negative charge. This one upon reaction with carbene, singlet carbene. Then we are getting product here. This double bond O. Here CH3. Here CCl2 minus. See here what happened. After formation of this product, means after attacking of CCl2, to which carbon that electrophile has to come and attach, from that carbon only H plus has to leave. But here there is no H plus. Instead of that, which bond is there? Methyl group means carbon-carbon bond is there. So carbon-carbon bond is not going to break. Here this one also carbon-carbon bond and this one also carbon-carbon bond. In such a case, bond is not going to break. If this one abstracts proton, we are getting CHCl2. Means in such a case, are you observe that ring is going to attain aromaticity? There is no possibility. Here ring do not reattains its aromaticity because of here CH bond is not there and this one is not involved in tautomerization like that. And if this one further hydrolysis, you are getting CHO. So we are getting product here CHCl2. Instead of that benzaldehyde derivative. You are not getting any benzaldehyde derivative. So if para position is blocked, you are not getting 100% ortho, but instead of that, along with that ortho, para also possible. But the para product is minor again because of this. In this case, ring loses its aromaticity. In this formation of this product, you are getting aromatic product benzaldehyde, right? So here this one is possible, means this is a major and this one is a minor, but you are not getting 100% product, right? Now, if ortho position is blocked, that means you need to consider here O minus and here CH3. In such a case, CCl2 has to come and attack in para position. So I am going to take directly that structure only instead of this one. So para product, here we are getting negative charge. Now this negative charge one has to come and attach upon this carbon, and what we are getting? Double bond O, CH3, here CCl2 minus and H. And finally it has to lose its H plus and to reattain its aromaticity, and ring reattains its aromaticity. Here we are getting CHCl2. After hydrolysis, what product we are getting? OH, CH3 and CHO. So if ortho position is blocked and it means here who? CCl2, neutral carbene do not prefers to go to ortho position because ortho position is already hindered and it prefers to go to para position. In such a case, maximum product you are getting para. Whereas if you block para, then still it has tendency to go to more ortho along with para. So even though you block para position, you are getting both products, para and ortho. Whereas if you block only para position, only ortho position, in such a case you are getting only para product, and attacking at ortho position is very, very less. This is Riemann-Therman reaction. Now, the same Riemann-Therman reaction also takes place by using carbene instead of chloroform. You can also use carbon tetrachloride. In case of carbon tetrachloride, this formula is CCl4. From here, if one Cl minus departs out, here you are getting CCl3. Let us see that mechanism here. So, when we are using CCl4, from CCl4, CCl3 generated. How CCl3 generated? Let us see. Here phenoxide again. In terms of base, phenol exists as phenoxide. Now this phenoxide resonance structure, let us consider negative charge in ortho position. That structure we are going to consider. This one upon reaction with CCl4, and this one is nothing but when phenoxide carbon C minus has to come and attach to the carbon, and from here Cl minus departed. So what is the difference in mechanism? In case of chloroform, carbene is generated and the carbene acts as electrophile, but here there is no carbene. Instead of that, phenoxide ion only has to come and attack upon chlorine containing carbon. So this one, what do you say? Which type of substitution you are going to say? Reverse from rear side. Remember that SN2 mechanism, here CCl3 and H. Now again it retains its aromaticity. In order to retain its aromaticity, what happened? It gets back its pi electrons and it converts into phenol derivative. So here OH and we are getting CCl3. This one upon hydrolysis, we are getting here 3Cl minus comes out as 3Cl minus, instead of that 3OH minus, and as we know that no one carbon is going to bear more than 2 OH groups, it loses water molecule immediately and it converts into orthohydroxybenzoic acid. Orthohydroxybenzoic acid is what we call salicylic acid. So Remer-Tammann reaction, what will end? Phenol upon reaction with the chloroform in presence of alkali gives orthohydroxybenzoic as major product and para-hydroxybenzoic as a minor product. Why orthohydroxybenzoic major product? Because of reason is intramolecular hydrogen bonding. That's clear. What happened if ortho position is blocked? You are getting maximum para product. What happened if you block para position? You are not supposed to get 100% ortho product. Instead of that, along with ortho product, para product also formed. But para product is not resonance, means aromatic compound. Ortho product only aromatic compound. That mechanism already learned. Now instead of carbon, chloroform, trichloromethane, if we are using carbon tetrachloride, what happened? In case of carbon tetrachloride, we are getting acid, but not aldehyde. That acid what we call salicylic acid. So salicylic acid we are getting in Remer-Tammann reaction. Now let us see this one. We know pyrrole. If instead of phenol, if pyrrole is a substrate, pyrrole upon reaction with chloroform in presence of alkali, you are getting two products. Have a look here. In one product, with respect to nitrogen, adjacent carbon gets aldehyde, whereas in another product, you are getting 6-membered ring, means a pyridine product, pyridine derivative. How you are getting these two? As is well here. First step, CHCl3 upon reaction with alkali. Here H2O comes out, we are getting CCl3 minus, and from this CCl3 minus, Cl minus departed, and we are getting neutral bivalent electrophile carbene. Now this carbene has to come and attach the electrophilic center, nucleophilic center. Here nucleophilic center, here nitrogen lone pair is involved in delocalization. Hence CCl2 has to come. This one need electron, this center is electron rich center. Now what happened? In between these two, reaction takes place. We are getting product like this. Remember what product we are getting? This product. How we are getting this product? As we mentioned that here 2 electrons, let us assume, but it is not real. 2 electrons here 2 electrons. Means bond means 2 electrons side. And in between these two, bond formation takes place. That we can show like this. But actually what happened? This one is going to accept electron and finally you are getting negative charge, right? So after formation of negative charge, again back bond means reverse bond formation, you are getting 3-membered ring. And later this one upon reaction with the base, this base abstracts a proton from nitrogen, resultant these electron will go like this and this electron will shift and this Cl has to come as Cl minus. I am repeating once again, CCl2 is a neutral electron deficient species. This neutral electron deficient species approaches electron rich center. Here double bond is located in between these two. Here it comes to this center and there will be a formation of 3-membered ring. And after formation of 3-membered ring, base has to come and approach this proton, abstract this proton, and this NH single bond electrons will be shifted towards adjacent carbon. And because of 3-membered ring strain is more. Hence it turns to 6-membered ring by opening this ring 3-membered ring. Here these electrons will be shifted towards next carbon and in order to facilitate the electrons, the Cl has to come out as Cl minus. Then what we are getting product here? This carbon, there will be a formation of 6-membered ring, nitrogen, here double bond. Next position is this one, in between these two double bond, and here also double bond. Now with respect to nitrogen, this one is first carbon and second carbon. So this one is first carbon, this one second carbon, one Cl left. Now it remains only one Cl. This is Riemann-Thermal reaction with pyrrole and with phenol. So we can use chloroform. If you are using chloroform, you are getting aldehyde product. When you are using the carbon tetrachloride, you are getting salicylic acid, orthohydroxybenzoic acid, salicylic acid product. And remember that this salicylic acid upon acetylation, CH3CO taken twice O, then O-acylation takes place, OCOCH3 and COOH. It is nothing but acetyl salicylic acid. Acetyl salicylic acid, nothing but aspirin. Acetyl salicylic acid, nothing but aspirin. Okay. So regarding Riemann-Thermal reaction, this much. So in Riemann-Thermal reaction, we learn that phenoxide ion is going to take part in resonance structures, and you are getting negative charge in ortho and para carbon. The ortho and para carbon containing negative charge is going to take part in the reaction with dichlorocarbon. I have a doubt. Why not O minus is going to take part in the reaction? You got my question? In phenoxide ion, O minus is there. That O minus may directly participate in the reaction with the CCl2. Then there will be formation of OC direct bond, right? Why? That will not happen. Why? Carbon or the para carbon is going to take part in the reaction. And my second question is, which elimination here takes place? In the beginning of elimination reactions, we learned a few types, alpha, beta and gamma. While formation of carbene, base has to come and abstract proton from chloroform, and CCl3 minus formation, that from that CCl3 minus Cl minus is going to depart, and we are getting ultimately CCl2, dichlorocarbene. So this elimination, what we got? You have to think about that. Let's come to next property, carbyl-amine reaction. Carbyl-amine reaction also called phenyl isocyanide test. Phenyl isocyanide test. Riemann-Thermal reaction and carbyl-amine reaction, these two are very important properties of chloroform, and carbyl-amine reaction also used as test for both chloroform and primary amines, because this reaction is performed by only primary amines. So this reaction is performed by only primary amines. Immediately we are getting, why not for secondary and tertiary amines? You have to think. So if you want to know that, first of all you should learn the mechanism. Okay. So this reaction is for only primary amines, and this reaction also used as test for both primary amine and chloroform. Means if you know primary amine, you can use for test for, you can use as test for chloroform. If you know you have chloroform, you can perform test for primary amine. Okay. So this one we can use both, test for both primary amine and chloroform. Let us see what mechanism here proceeds. I am going to consider aromatic amines. This reaction is given by both aliphatic amines and aromatic amines. Both aliphatic amines and aromatic amines, means RNH2 also and ARNH2, both products can perform this reaction. Let us see. Aromatic amines, I am going to consider aniline. Aniline upon reaction with chloroform in presence of base, we are getting phenyl isocyanide N triple bond C. This is the reaction. Along with this KCl and H2O are byproducts. Just like the prior mechanism what we learned means Riemann reaction. Here also first step formation of carbene means CHCl3 upon reaction with base. This base has to abstract proton from carbon and we are getting CCl3 minus and H2O. This CCl3 minus from the Cl minus departed and we are getting dichlorocarbene. This dichlorocarbene acts as here electrophile, neutral, bivalent, electron deficient species. Neutral, bivalent, electron deficient species. Now here this nitrogen containing lone pair again involved in resonance. Because of that ortho and para position, para carbons gets negative charge, right? But here if you observe the product, there is no bond formation between C and C. Instead of that, nitrogen is only going to take part of the reaction. That means here aniline upon reaction, NH2 upon reaction with CCl2. So nitrogen is going to donate electron pair to vacant orbital of carbon in carbene. Then we are getting NH. Right now nitrogen base positive charge because of it is giving electron pair to carbon. Then C it is going to bear negative charge because of it accepts electron pair from nitrogen. So carbon negative charge and nitrogen positive charge. So whenever carbon acquires negative charge, immediately Cl try to leave away. Whenever nitrogen bears positive charge, this one pulls that NH single bond electrons towards itself. Then what product remains here? If you observe N, still one hydrogen is there, one hydrogen left, it means HCl comes out here and a hydrogen, here C and Cl. Again it comes to carbene type, right? So here nitrogen again donates electron pair into vacant orbital of carbon. So this happens at a time means when Cl departed, this one also you can write like this. Then direct reaction or this one. If you write this one, again you have to write resultant product, or instead of writing this one directly you can also write N double bond CClH plus. I am repeating once again. CCl2 neutral carbene, then into that neutral carbene nitrogen is going to donate electron pair. When nitrogen donates electron pair, there will be new bond formation between nitrogen and carbon. The difference between Riemann reaction and carbon-amine reaction is there carbon-carbon bond formation takes place, here nitrogen-carbon bond formation takes place, and after formation of that nitrogen bears positive charge and carbon bears negative charge. Here whenever this nitrogen in order to compensate its positive charge, it pulls electron pair towards itself, and simultaneously from CCl, Cl has to leave as Cl minus, then you are getting N double bond C. And right now here carbon do not have carbon. Whenever this Cl comes out as Cl minus and these electrons are shifted, still nitrogen carbon bears negative charge, or you can write in two steps. Here whenever this nitrogen get back electron, its positive charge compensated, now it comes to neutral, and when Cl departs as Cl minus, its negative charge compensated, it remains as carbon. Now again nitrogen donates electron pair to vacant orbital of carbon. Then carbon again acquires negative charge and nitrogen acquires positive charge. Now, again this bond electron shifted like this and this Cl has to leave. Then we are getting product N triple bond C. So, this one is plus, this one is minus. Also we can show this phenyl isocyanide because of N. Here double bond C, one is dead bond. This one is called the phenyl isocyanide, also called the carbamine reaction. And formation of this phenyl isocyanide and carbamine, phenyl isocyanide also called the carbamine, NC carbamine. Whenever it forms, it gives unbearable smell. It gives unbearable smell, and this phenyl isocyanide formation Whenever formation takes place in the laboratory, immediately you are getting vomiting sensation. So prior to formation of this product, you are getting vomiting. So that is the main symptom for formation of phenyl isocyanate. Of course, you are not supposed to get the product finally. So prior to the formation of product, we are going to stop the reaction. Means you need to prevent the formation of phenyl isocyanate, because if its formation takes place, the smell is quite unbearable. Hence, we are not going to bear that smell. Because of that one, we need to stop the reaction. In order to stop that, again we need to add HCl, because if you observe the reaction, here HCl molecules are eliminated. When you add again HCl, then it prevents the formation of phenyl isocyanate. If any phenyl isocyanate formed, then immediately converts into NH2, aniline. You got the point here. So, carbylamine reaction is test for both chloroform and primary amines. And once again, phenyl isocyanate is given performed by only primary amine. Now let's come to the first question. Why only primary amine? What happened to secondary and tertiary amines? So if you consider secondary and tertiary amines, is there any possibility to break that NC bond? Here NH bond is going to break down step by step. Such a bond breaking is not possible in case of secondary and tertiary amines. That's why secondary and tertiary amine do not give this reaction, isocyanate test for carbylamine reaction. And it's a test for both the primary amine and chloroform, yes. And both aliphatic and aromatic amines, here that ring, with respect to that ring, there is no importance here. Ring participation is not there. That's why whether it is aliphatic or aromatic, ultimately that nitrogen should attach to some electron releasing group, electron pushing group. If it possesses any electron withdrawing group, in such a case, the tendency to donate the lone pair of electron is less. So electron releasing groups more favors the carbylamine reaction. We can say like that. Electron releasing group favors the carbylamine reaction, whereas the electron withdrawing group not favors that much. And aliphatic amine and aromatic amine, first step formation of carbene and dichlorocarbene. Here nitrogen directly participated in bond formation. Now my question is, in case of Raman reaction, there you mentioned that OC bond formation does not take place and CC bond is formed. Okay, fine. In such a case, better to here also nitrogen lone pair is involving in delocalization. Hence, CC bond formation also takes place. But why you are saying NC bond? Think about that. And after formation of that NC new bond, because of Cl strong electron withdrawing group, because of Cl strong electron leaving group, because of leaving group strong electron withdrawing group and more leaving tendency. That's why it has a leaving tendency, and nitrogen is going to donate its lone pair. Ultimately, there will be formation of triple bond in between these two. Now, if instead of dichlorocarbene, I am going to consider CH2 only, means carbene CH2 only, then shall we get the product? Think about that. These are the chemical properties, and chloroform we are using as solvent for fats, waxes, resins, etc. Chloroform is good solvent. And also chloritone, just we discussed earlier, chloroform with acetone, it forms chloritone. It forms chloritone, that is condensation product, that is used as hypnotic drug. And chloroform upon reaction with nitric acid, it forms chloropicrin. Chloropicrin is hypnotic drug. And similarly, this one also used as test for primary amines, just now we discussed. And chloroform once upon a time it was used as anesthetic, but because of it causes liver damage, that's why we are not going to use. And instead of that, we are going to substitute halothane. Halothane is CF3CHClBr, that is halothane. And instead of that, isoflurane is CF3CHClOCHF2, that is isoflurane. And right now, one of the best refrigerant is Freon R22, and the trade name of R22, that is Freon, which we are using in our air coolers, ACs and refrigerators. This R22 formula is CF2CHCl. CF2CHCl also indicated as HCFC22. R22 also called HCFC22. These are the uses of chloroform.